Hello, my name is Professor Stephen Wright, and my inaugural lecture explains my background, my research, and my active interests. I'm an industry professor specialising in aircraft engineering. My interest includes how the aviation industry will change from the reliance on fossil-based fuels to make travel greener and accessible. Likewise, new technologies are needed to make the industry safer and to minimise the risk of mishaps occurring. For example, streaming all the aircraft's performance data via satellites to ground stations will make the aircraft much safer and predictable. My early aviation career started overseas in the Far East, working for flight operations at Cathay Pacific Airways in Hong Kong. Later, I moved back to the UK and worked for part of the British Airways group based at London Gatwick Airport, where I set up an engineering training school and conducted various engineering classes and programmes. After the 9/11 attacks, I changed employer and with a UK company set up a division of Lufthansa technical training based in the UK. Initially, I was the training manager gaining all the UK approvals, but later was promoted to the quality manager. In 2003, I was appointed a senior lecturer position at Kingston University, where I taught on the EASA-approved degrees. I set up various degree programs that are tailored to the industry needs for both aircraft engineering and pilots. In 2008, I changed university, this time to the University of Leeds, which is a founding member of the UK's Russell Group. I gained my PhD in aircraft engineering at Leeds. I also gained my EASA pilot's licence. I investigated the failure of aircraft heat exchangers due to fouling operations. The work synthesised the operational fouling and clogging of a wavy plate fin heat exchanger that's the critical component in the aircraft's air conditioning system. The air conditioning system is a critical life support piece of equipment that's necessary for large commercial aircraft. The air conditioning system provides the fresh air for breathing, warmth, because outside it's usually around -57 Celsius in the cruise, and lastly, pressurisation to the aircraft. The image shows the red line taking hot bleed air from the jet engines. On the ground, this hot bleed air is cooled by passing it through a heat exchanger, compressing the gas through another heat exchanger to cool it again, through a water extractor, and then expanding it through a turbine before the air is ducted to the cabin. In flight, a packed bypass valve opens to allow the hot air to reach the passenger cabin. There are usually two systems fitted for safety. If one fails, you land as soon as practicable. However, if both air conditioning systems fail, then the aircraft must make an emergency landing because passengers can't hold their breath for long periods. I have several postgraduate student PhD completions from the University of Leeds, including fields such as flight crew error, human performance in Middle East conditions, fatigue, and the operational effects, and so forth. I was recruited to Tampere University and took up my post here in January 2019. Current teaching includes the Masters in Aeronautical Engineering programme. I'm involved in establishing other degree programs at Tampere University for aviation professionals because it's important to recognise the professional achievements of EASA licence holders. My research interests include the European Commission's ambition for clean and green aviation, known as Flight Path 2050. I'm working very closely with a major European aircraft manufacturer, Diamond Aircraft Industries. The big research projects involve the removal of traditional fossil fuel powered engines, fitting electric motors and propellers in their place, motor controllers and either battery packs or hydrogen tanks and fuel cells. This is perhaps the most exciting step change in aviation since the Wright brothers' first powered flight, because the resilience on fossil fuels and the production of carbon dioxide in flight would be fully removed. These aircraft are ideally positioned to the industry and could be certified by the manufacturer to enable flight training activities to take place on these new powered planes and no fossil fuel emissions would be incurred. Additionally, the operator would make a large financial saving, as the electric and hydrogen operations are believed to be around 15% of the current operating costs. Other research includes the operational fouling of additive heat exchangers and additive test samples that are provided by Technical University Hamburg-Harburg, TUHH. This is a joint research activity and is very topical to new manufacturing techniques destined for the industry. Lastly, as an aviation expert, I'm frequently asked to give professional comment to the world's media on various aircraft incidents and accidents. Naturally, coming from the commercial industry, I have an operational insight outside of university. I've recently written and published a book titled Aviation Safety and Security, Utilising Technology to Prevent Aircraft Fatality, published by CRC Press. The book deals with historical aviation safety events through history, the need for the introduction of black box flight data and cockpit voice recorders. Additionally, a number of security-themed events are discussed, including the disappearance of MH370 and the possible modus operandi of the perpetrators of that flight. Finally, the book suggests how the new technologies will likely be employed to improve engineering reliability and latterly to prevent similar occurrences from reoccurring. In closing, aviation is a very important transportation means that will only become more frequent in the coming years. My role is to support the industry with green-focused research to allow the industry to become more uncoupled from the needs to use fossil fuels and to suggest and foresee new technologies that will make aviation safer, faster, greener, and more accessible to all. Thank you for listening.